Good afternoon from Miami Beach. This is Dr. John Bennett broadcasting for Neurosurgical TV. We have number 4 in the series of neuroanatomy arranged by Ulrich Sidney, a medical student from Cameroon. It's a series of webinars, and we're pleasured by the presence of world-renowned neuroanatomist, Victor Hugo Perez. But before we turn it over to Victor, let's introduce the students to Victor. Hello, Dylan. Could you please introduce yourself to Victor?
Hi, Victor.
Hello. How are you?
I'm Dylan.
Victor, what year are you, Dylan? What year student are you?
7th year medical student.
Okay, welcome. And Natalie, who's going to present after Victor, could you please introduce yourself? And Ulrich.
Hello, I'm Natalie Gomsi from Cameroon. I'm a medical doctor already, and I think I'm the second presenter today.
Okay, and Ulrich?
Hola, soy Ulrich Sidney. Nice to meet you.
Él está aprendiendo español.
Do you speak Spanish?
Hablas un poquito español. Mi español está muy bien. Un poco.
Excelente. A little bit.
Poco.
Yeah.
Okay, Victor, welcome, and it's all yours.
Okay. Nice to see you again. We are going to talk today about a special staining of some brain cuts. So this is very interesting because let me put this one, the conference in here. So while screening, so can you see? Can you see it?
Yes.
Yes?
Yes, we can.
Yes.
Mulligan staining. Well, I have the honor to be a member of the Committee of Neurosurgical Anatomy of the World Federation of Neurosurgical Societies. That's the reason I am very interested in showing some techniques and some aspects, really interesting aspects of the brain and spinal cord. So what you are seeing in this slide is a sagittal cut of a brain. So if you see a brain cut, it's difficult to understand the anatomical parts of the brain. For example, here we have the frontal lobe, parietal, occipital, and here we have the cerebellum and the olive nuclei. So here is the midbrain, pons, and medulla. So we are going to see several cuts. Like here we have the callosum body. This is the callosum body. The cingulum. Look at this. This is cingulum. So and here we have some nuclei of the brain. So this is a close view of brain stem, the middle, the midbrain, the pons and medulla, and also cerebellum. So after seeing this, I want you to see what we are doing. This is the staining of some brain cuts. So in order to see much better the structures of the brain. For example, in this cut, you cannot differentiate some parts of this cut. It's difficult, but if you stain only the gray substance, you can differentiate the white substance and gray substance. For example, in this. So this is the result of the anterior coat. This is the coat without staining and the coat after staining. So we can differentiate some structures of these coats. For example, in here. Here we have the anterior nucleus of thalamus, the head of caudate nucleus, cuneus, calcarine sulcus, globose nucleus, medial lemniscus, superior cerebellar peduncle, red nucleus, substantia nigra, and ventral anterior nucleus of thalamus. But where are they? So if we try to differentiate these structures in this coat, I think that it's a little difficult to do that. But if we stain the brain coat with some staining like mulligan stain, look at this. Now we can differentiate much better these coats. For example, anterior nucleus of thalamus. This is the anterior nucleus of thalamus. The head of caudate nucleus. The cuneus is in here. Calcarine sulcus. Here we have the calcarine sulcus. Globose nucleus. This is globose nucleus. Medial lemniscus is in this part of the brain. These tracts are not stained because, you know, what we are staining in this brain coat is only gray substance. So that's the reason you can differentiate the tracts. For example, in this. This is the superior cerebellar peduncle, this one. We have the red nucleus in here and the substantia nigra in this part. So let's go to see another one. Here we have the genu of corpus callosum, the claustrum, frontal operculum, the insula, the splenium of corpus callosum, choroidal plexus, posterior limb of internal capsule, the putamen, and head of caudate nucleus. Here, putamen and head of caudate nucleus, and column of fornix. So, yes, I agree. You can differentiate and you can visualize these structures in this axial coat. But let's go to see with a mulligan staining. This is really beautiful because you can differentiate very, very well these structures. Here, we have the genu of corpus callosum, then claustrum in this part. With number 3, the operculum. The 4th is insula. Number 5, splenium of corpus callosus. 6, choroid plexus. 7, posterior limb of internal capsule. Look at this. What's the reason you are seeing the internal capsule in color white? It's a question. What's the reason you are seeing the posterior limb of internal capsule in color white? And why you can see the head of caudate nucleus with this color, in color blue? Why?
The internal capsule is made up of white matter. It is
Yes.
it's made of the axons of the pyramidal cells from the cortex, whereas
Yes.
the gray myogray sample.
Caudate nucleus is
The
made up
caudate
of-
nucleus is made up of gray matter.
Agree. Okay, perfect, perfect. So that's the reason you can differentiate white substance and gray substance. For example, the head of caudate nucleus is in color blue, and this is the column of fornix. So, okay, this is another coat. This is a really beautiful coat, and let's go to see this another axial coat. The hippocampus is number 1, para hippocampal sulcus, vermis, basis of pedunculi, and substantia nigra. But it's difficult to differentiate. But in some, if we stain these coats, we are going to differentiate very well. So this is a variation of the Mulligan state. This is also a staining, but in this case, you can see the gray substance in color brown. So this is a normal coat and coronal coat, but this is with the variation of Mulligan staining, and in this variation, you are not going to get the color blue for gray substance. Instead, this is in color brown, but it's also a beautiful method to differentiate this staining. Here, for example, we have the hippocampus in number 1. Look at this. This is a really beautiful axial cut. This is the hippocampus. The parahippocampus or parahippocampal sulcus. The basis of peduncle, this is this one. And in number 4, the substantia nigra. This is in Spanish, sorry for this, but this is how to make this technique of Mulligan. It's not difficult. If you look for Mulligan staining in internet, you can get the method to make this kind of staining. The only one is you need some for example, some staining. I think the most difficult to get is a brain, a very well fixed brain, in order to make a good cuts. So you need also with this preparation is with some heat, 65 degrees. This is Mulligan with copper sulfate. We are taking temperature in order to put in there the brain coat. The second step is to wash the brain coat in cold water. Then the third step is to put the brain coat in a solution with a ferric chloride. So then we put the brain coat in a solution with a ferrocyanide for 15 to 20 seconds. And look at this. This is the cut brain without staining. And then after, you can see how this brain coat is changing its color. All the gray substance is changing to color blue. This is like magic. This is a magic step. If you want to train doing this technique, you can make this in pig brains, in pig brains. The brain of a pig is you can get this the pig brain very easy. It's easier to get that kind of brains. For example, in this frontal view, look at this. In the left side, we have a coronal cut without staining, and in the right side, after the staining. Look at this slide. Is really, really beautiful to make this staining. Again, for example, the putamen, the pallidus nucleus. Here we have the thalamus and the caudate nuclei. This one, and some parts of the pons. Let's go to see what's happening with this mulligan state. In here is easier to see and differentiate the structures. For example, in this one, look the hippocampus is really, really beautiful to see this part of the brain. This is another cut. After the staining of mulligan, we can get this, the olivar nucleus in the medulla, the pons. This is the what is this tract? This is a question. Can you see this tract? This is the other one. This is a corticospinal tract. Now we are going to see several cuts of this brain. I put first of all, I stained all the cuts of this brain, and then after I'm going to remove this. Excuse me. Sorry. Okay.
Are you okay there, Victor?
Yes.
Okay.
Can you hear about? Can you hear?
Are we supposed to hear the video? No, we don't hear the video.
Ah, okay, okay. I thought that you can hear the video.
Well, you know what you can do, Victor? You can restart the screen share and click on the option to hear the sound. Do you want us to hear the sound?
Okay, no problem.
Okay.
It's very short.
Okay.
So I am removing the coronal cuts of this brain. So I think this technique is very useful to understand the anatomy of some tracts of some nucleus, cerebellum.
So, Victor, sorry.
Yes,
Um,
yes.
Is this like a double staining? Because what we saw before was like reddish in staining. Right now we see red and blue. Did you do two stains on the?
No, this is, I think, like some artifact, some variation of the temperature, and that's the reason some of them are, got very well the substance, and other didn't get the chemical reaction. So that's the reason.
Okay, thanks.
So if you want some day I can show you how to make this step by step. So it's not difficult. The most difficult is to get a human fresh brain. First of all, you need to fix the brain with formol, and after 15 or 20 days you should remove all the arachnoid with vessels, and then after to make very good cuts, very nice cuts, precise cuts, and then after to get the substance, the chemical substance, and it's not difficult to make this kind of staining, and you are going to learn very well the internal anatomy of the brain. So I think this is very important to understand. Neurosurgery is a really difficult discipline, because you need to know internal, external, so many anatomical structures. So that's the reason I wanted to show you this Mulligan state. And in the next conference, I'm going to show you the external conformation of brain with some videos also. So in this moment, I finish this talk.
Okay, very good, Victor. Thank you very much. As always, a great presentation. You know, Victor, we're going to televise next week a live cadaver dissection from Nairobi, Kenya, next week, and for a couple of days in the lab, cadaver lab in Nairobi. They have a cadaver lab there, and we're going to try to get in on the brain dissection, and I'll let you know about that. And you're also invited to, to come in and check, see what they're doing over there.
When is it going to be?
It's going to be, I think, the Friday and Saturday, I believe, next week.
Okay.
Okay, I'll let you know. But we're going to have to hook up the setup, so we have an overhead camera and a microphone on the dissector. You've probably done them before, right? In laboratories that are set up for it.
Are you going to Nairobi?
No, we're gonna televise it from here. But I mean, the students there are having a conference, a cadaver lab, and we're gonna televise it.
You should go there. You are the star.
Yeah, I would love to. I would love to, Victor. And I told Nathalie, I think I would love to go there. especially if we find a good group of enthusiastic kids that will help the project. Yeah, I'll go there in a heartbeat.
Good, good.
But yeah, I think most people don't realize the work you put in these sections. You dedicate pretty well your life, right, to anatomy.
Yes.
Yes, full time. You probably don't do much surgery, right? A little bit of spine. What do you do now, Victor, in the OR?
Well, I spend more time in doing some research of mainly in arteries and veins of the spinal cord.
Okay.
So that's my in this time I am working in doing that kind of research. Yes.
And are you affiliated with the university, like UNAM or another university there, doing
Yes,
that research?
No, in the Forensic Sciences Institute in Mexico.
Okay. Oh, okay.
Yes.
Can you show us that website, please?
Website?
Yeah, they have a website.
Oh, I don't know.
Okay,
now.
don't worry about it. Don't worry
Okay.
about it. I was thinking.
Okay.
So you're head of the Forensic Society. Go ahead, Natalie.
This I have a question.
Go ahead.
Dr. Perez, how do you do so that the cerebellum should just be clean, just clean like that? And at what temperature do you do your staining?
Okay. This Mulligan staining is you can look for this in internet. So there are too much information about this Mulligan staining, but if you want, I can show you how to do this. You can do that in pig brain, because pig brain is not a small, is good size, the pig of the brain of a pig.
Well,
So it's easy to get a pig brain. So after this, you need to fix it in formaldehyde, and after 15 or 20 days, remove the arachnoid with the blood vessels, and then after to make the cuts. And after that, to get the substance to make this kind of staining.
So a period of 2 weeks, huh? You have to wait?
3 weeks, 4 weeks, more or less, yes.
Okay. After the injection of the latex?
No, this brain is not injected. It's only the brain.
Okay. When does the latex get injected? At what stage?
No, in no stage.
Oh, it's different. Oh, okay.
The staining is for this.
Oh, okay. This is something totally different. Oh, I'm sorry.
Yes, yes.
Okay, I'm sorry.
At what temperature is it supposed to be stained?
65 or 70 grades. Centigrades.
Thank you.
You're welcome.
Ulrich, you okay? Marco, are you okay? Hello, Marco.
Hello, Marco.
Hello, Marco. Nice to see you.
Nice to see you again, all people. And thank you for the presentation, Victor. It's absolutely nice and is wonderful how the neuroanatomy lesson made by a neurosurgeon, I think, is the best we can desire. Thank
yes,
you.
it's good to see that, because you are going to get very useful information about the anatomy. So
That's right.
I think it's good, yes.
And I guess you must know why it's important in certain places that you know that anatomy for certain cases. I guess there's certain parts of the anatomy you have to know very, very good. I mean, you have to know it all, I guess. That's a dumb question. I'm sorry. Or dumb comment. But I'm not a neurosurgeon, so I get a break. Okay, we have another guest there. Hello there, G-Flex2. Can you introduce yourself to Victor? G-Flex, go ahead. Are you there, G-Flex? Well, maybe not. Okay. Okay, Victor, thanks a lot. And you're welcome to hang around if you like. And I believe Nathalie is going to present on the occiput. Is that correct, Nathalie?
Yes.
Natalie? I hope she didn't leave us. She may have just been bumped off. Sometimes that happens with.
I really sorry because right now I am leaving to
Okay,
Puebla.
no problem, no problem, Victor, no problem.
But sorry.
Okay, thank you very much for your time.
Next week we can talk about the external anatomy of brain and spinal cord. I'm going to show you some videos. So thank you so much.
Okay,
it's
great,
really
Victor.
a pleasure. I feel very honored to be with all of you.
Well, I know the African kids love this, Victor. And we're going to show it to a lot of people. During the week, it's a little busy. Students are working, etc. But they'll be able to see the video. They'll be able to see the video, which we will archive with the other 7 videos of the series.
Yes.
So we also invite you next week to the presentation for the cadaver lab from Nairobi. I'll let you know on that. So we're going to end this, and we'll start on Nathalie's. Thanks, Victor.
Thank you. Thank you.